Hello, everyone. On this video, we are going to have a laboratory activity. For gravitation. This activity's objectives are: number one, determine the factors that affects the force of gravity on objects. The second objective will be calculate the force of gravity between two objects using Newton's law of universal gravitation. What we need on this activity is the PhET interactive simulations using the gravity force lab. So we are going to visualize the gravitational force that two objects exert on each other. We adjust properties of the objects to see how changing the properties affects the gravitational attraction. So this material can be accessed through an internet connection. What we are going to do on this activity: first, we use the gravity force simulation to explore the gravity. As we explore the situational or the simulation, observe the changes that will happen on the gravitational force. And then we identify two ways that we can change the amount of force or gravity the objects experience. After we explore the simulation, it is now time to answer the data table by manipulating the values based on what is given on the data table. So we have for mass 1, 25 kilograms at 3 meters, while mass 2 at 25 kilograms, just located at 7 meters. Then we have 25 kilograms on next trial for mass 1 and located at 1 meter. For mass 2, still 25 kilograms and located now at 9 meters. Then for setup number 3 or trial number 3, we have 100 kilograms, still located at 1 meter. And then for mass 2, we have 100 kilograms, which is located at 9 meters. Then at setup number 4 or trial number 4, we have 100 kilograms, 1 meter, still located at 1 meter. And then the mass of the second is 1 kilogram. And the location of our object is at 9 meters. We are going to determine the force of attraction for 1 on 2 and the force of attraction or the gravitational force on 2 on 1. So let's proceed to our PhET simulation. The moment that we click the PhET simulation gravity force lab, so this is what we are going to see. So we have here our mass 1, which is in blue, and our mass 2, which is in red. So we can notice that we have the vector arrow here, which represents the direction of our gravitational force. Okay. So we have a value of force on M1 by M2, or the force by 1 on 1 by 2, which is 0.000000166,852. So we can change this into scientific notation by just clicking the force values. So we have 1.67 times 10 raised to negative 7 newtons. And then we have here force on M2 by M1, which is equal to 1.67 times 10 raised to negative 7 newtons. So if we are going to change the values of mass 1, just need to scroll this blue dial here. Can make it bigger. So you can notice that the arrow, the vector arrow here, or the force arrow here, is changing as well. So for mass 2, we can also change the mass or the value of mass. So you can notice that as the arrow changes its length, the value of the force acted on M1 by M2, or the force acted on M2 by M1 changes as well. If both have the same mass on similar separation distance, this will be the number of force, or the amount of force that is being exerted by each on each other. Now, if we're going to move our objects, we will notice that there is something that is happening as well on the amount of force between the two objects. So if we are going to make them near to each other, you will notice as well that there is, or there are changes that is happening between the two objects. Okay. So we can hide also the amount of force, and we make it on a constant size, whether it's bigger or lesser. So in say constant size, the size is the same, but the mass differs. Okay, we want to put it this way and say that it's getting bigger as the size also increases. So what we are going to look into is to use the scientific notation and with not using the constant size. So again, let's have one which is smaller mass and the other two which is a higher mass. So as we move M1 far from M2, you will notice that there is a difference between the amount of force. So as we are done exploring the gravity force lab, we are now going to simulate the data from our data table. So the first one, setup one or trial one, we have mass 1, which is equal to 25 kilograms. So we will change M1 to 25 kilograms. Here, we are going to calculate for the force on 1 by 2 and the force on 2 by 1. So here, it's already 25 kilograms. Our M2 will be 25 kilograms as well. So both now has 25 kilogram mass, and we are going to place M1 at 3 meters. Okay, so that's M1. M2 now is at 7. So as an example, we have here that the force on M1 by M2 is equal to 2.61 times 10 raised to negative 19 newtons. We can calculate this through the Newton's law of universal gravitation, where Fg is equal to the gravitation constant, G, capital letter G, which is multiplied to the quotient of M1 times M2 divided by the separation distance squared. So we are going to multiply the constant G for universal gravitation to the quotient of M1, M2, and the separation distance squared. So if we are going to go back to the lesson that we had on gravitation, we can use the formula to identify the force. So this is for trial number 1. So for trials 2, 3, and 4, I am going to hide the value of the force because you are going to calculate the force for setups 2, 3, and 4. Okay. So let's have now setup 2. Here we have the same amount of mass at 25 kilograms for both masses. And we are going to change the location from 3 for mass 1 to 1 meter. While we are going to change the position of M2 from 7 to 9. So we are going to calculate now the force acting on M1 by M2, and or the force acting on M2 by M1. You're going to notice that the arrow is much smaller compared to the ones that we have before we do this activity. As we just explore the simulation, we have seen a longer arrows because we have a greater value on that exploration. Now that we are having the second setup, we have a much smaller arrows and we may not able to see it clearly or properly. Now we move on to setup number 3 or trial number 3, that all of these both masses have equal 100 kilogram mass. So both of them have 100 kilograms. So you have noticed that there is now a visible arrow pointing each other. And we are going to place it on the same, with the same separation distance, 1 at 1 and at separation distance for M1 at 1 meter and at M2 at 9 meters. So how are we going to calculate for the separation distance? Of course, we are going to subtract 9 to 1. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's move on to the next setup, the last setup. We have 100 kilograms at 1 meter. So that's M1. While M2 will be at still 9 meters, but the mass will become 1 kilograms. So that's 1,000 grams. So that's 1 kilogram only. So I don't have 1 kilogram. I only have 10 kilograms. So we are going to change the mass number 2 into 10 kilograms instead of 1 kilogram from our presentation. Okay, so we are going to calculate instead of 1. So this becomes 10 kilograms and this becomes 100 kilograms. Okay, so still at 9 meters and at 1 meter. So again, we are going to change this one into 10 kilograms since the simulation does not have a 1 kilogram tab function. So we have 25, 25, 110 kilograms for our mass 2. Now that we are done finalizing or computing for completing this table, can now move on to our discussions, results and discussion. So I want you to answer the following questions. How does, question number 1, how does changing the separation distance of the objects affect the force between them or between the two objects? The second one, what happens to the force between the objects when mass 1 increases? Then question number 3, what happens to the force between the object if mass 2 decreases? Then question number 4, what is the direction of the gravitational force acting on the objects? Then question number 5, what are the 3 factors that can affect the gravitational force between objects? For our application, let's answer. If the Earth's gravity is pulling you, are you pulling the Earth? Justify your answer. Question 2. Gravitational force is responsible for the attraction between objects based on their mass and the distance that separate them. Question, why aren't objects, like your pencil, being pulled towards you? I hope you answer all our questions correctly. So this activity is based on the fetcolorado.edu. So this is the laboratory activity for gravitation. Thank you very much and see you again.